Okay, so last time we defined some devices that our robot would use. Now we want to do an autonomous, right? Now let's say we want our robot to go forward 10 inches at a speed of 50. Well, great, this looks super readable, we know what it is, we know how far it's going at what speed. But the only problem is the microcontroller doesn't know what going forward means. All it knows is that it has 4 motors, a couple sensors, and a controller it's connected to. So we actually have to define what this go forward function is. So we'll do that up here. We'll say void go forward, and we want to pass it decimal numbers, that's what float means, as the distance. So we can give it maybe 3.4 inches or 90 inches or something like that. And we also maybe want to pass it at what speed it should be driving at. So this can just be as simple as an integer. And I believe this can only go from negative to 100 to positive 100, where negative numbers will make you drive in the reverse direction. Okay. Now we need to tell it. Okay. Now our problem is that we know how many inches the whole robot is going to move, but the robot only knows how many degrees each motor has rotated. So we're going to have to do a little bit of math on our own. Fortunately, this is pretty easy. So you can think of the distance that the robot needs to drive as the number of revolutions each wheel needs to make, right? So another way to put it, I guess, would be so you can think of the distance as the number of revolutions or complete number of degrees that your wheels have to turn. And this really translates to that the number of revolutions your wheel turns is the full distance that it needs to go divided by its circumference, or the distance around the wheel. So you can look up circumference if you don't know what it is. I'm not going to explain it right now. But it's basically just the distance around the wheel. So what we're going to do is we're going to create a decimal constant over here, and we're going to call it wheel if I can spell it right, circumference. And the formula is the diameter times pi, where diameter is the distance across the wheel, and pi is a constant, 3.1415, something or the other. So in my case, the diameter of my wheels are 4 inches, and then I'm just going to multiply this by 3.1415, which is pi. Okay, great. Now we need to translate this and this information into how many total degrees that each wheel needs to turn. And note that I'm saying degrees, not revolutions, because using degrees would mean a lot more precision with the measurements. If I tell you to go 3/4 of a revolution versus 270 degrees, I would assume that you would find 270 degrees a little bit more precise. You can even tune it to 271 degrees or 269.999. So that's why we're going to use degrees. So we're going to create a decimal variable called motor degrees, which will translate into how many exact degrees the motors need to go. And this is going to be equal to the number of revolutions it needs to go times 360, because of course that's how many degrees are in one revolution. And the number of revolutions it needs to make is simply the total distance it needs to go divided by the distance it would go in one revolution, or the wheel circumference. So we'll just say distance divided by wheel circumference. And then all of that times 360. And then the rest is pretty easy. All you have to do is tell the left motor to rotate 4, and then you just have to put in some information. The direction type, well, we're going forward in this case. Then you need to give it the number of degrees that it's going, which is what we defined right here, motor degrees. And you need to give it what units are we driving. Is this in degrees or revolutions? What is it? So in this case, it's degrees because we want as much precision as possible. Crap. And then we also want to be able to input how fast it should be turning. So we're going to say drive at this speed, and the units for this, you can have revolutions per minute or percentage. So where 100% is full speed. So we're going to say percent. And percent just tends to be a little bit more reliable than the others from what I've noticed. So that's why we're using percent. And then we just do the same thing for the right motor. All we have to do is call it the right motor. And that's that. Now, you probably also want to drive backwards. So we're just going to copy paste this because it's the same logic, really. All you have to do is change the name to go backwards. You're also going to be passing it how far it needs to go and at what speed. Then it's the same math, really. And then you just have to change the direction, right? Because you're driving in the opposite direction. Okay, then to turn, what? I'm making a video.
Where's the video?
It is on my computer.
I don't see the camera on.
And why does it need this camera on? I'm just recording my screen. I don't remember what I was doing. Okay. Okay, so for our next function, we want to be able to tell the robot how many degrees it should turn. We want to be able to turn left and right. So we're going to create a function called, let's do turn left first. And we're going to give it the number of degrees it should turn, right? That's what goes in the parentheses. Now, here's the fun part. The number of degrees that the motors turn is not the same as the number of degrees the entire robot will turn. And you're going to have to figure out, oh crap. So you're going to have to be able to translate the motor degrees to the robot degrees. So you can do this by just running the robot and seeing like how many degrees one revolution of the wheels takes you. So to turn left, remember that your left side is going to be going backwards and your right side is going to be going forward. Crap. Now, one quick thing about this is that if you run this code, what's going to happen is that the left motor is going to go forward first, and then the right motor is going to go forward first. But that's not what you want. You want both the motors to be running at the same time. If you've ever driven in a car and you step on the accelerator, it's not that the left wheels go first and then the right wheels go. Both sides are turning at the same time. So what we actually need to do is add something called false over here. And what this does is make it non-blocking. And what that means is that it's not going to wait for this command to finish before moving on to the next one. It'll say, okay, start the motors and start this one also. Like, don't wait for this one to finish, just move on. Okay, the next function that we want to do is turning. So let's create a function, void turn left. And we want to pass it how many degrees that we want the robot to turn. But keep in mind that the number of degrees that the motors turn is not the same as the number of degrees that... Okay, but keep in mind that the number of degrees the motor turns is not the number of degrees that the robot will turn. So you're going to actually have to find that on your own. So for me, for the most part, what happens is that, so we're actually going to create a variable up here, and we want to find how many degrees does the whole robot turn if we turn the left motors 1 full revolution backwards while turning the right motor's 1 full revolution forward. So when left goes back and right goes forward, you're turning left, right? So in my case, oh my god, okay, I need to explain this better. Okay, now, so for turning left, so turning left means that your left wheels are going backwards while your right ones are going forward. That would make you turn left on the spot. Now, you're going to have to find out how many degrees does your whole robot turn when each motor does 1 full revolution in the appropriate direction. So for me, we're going to actually store this in a variable called rev to angle, because it's the ratio of revolutions that the wheels make to the angle that the robot turns. So in my case, 1 revolution turned my full robot approximately 93 degrees. And you can fine-tune this later and increase it or decrease it if you realize that your turning function is not as accurate as you think it is. Okay, that was okay. And now in the function itself, so now in the function itself, we're going to kind of use the same thing as we did here. We have to tell the motors how many degrees they're supposed to turn. So we'll create another variable called motor degrees. And what this is going to be equal to, again, is the number of revolutions each wheel has to make times 360. So that gives you the number of degrees each wheel has to make, because, right, 360 degrees in a revolution. Now, since we have our ratio up here, rev to angle, it makes our math pretty easy. We just have to do degrees times rev to angle, where again, degrees is the number of degrees you want the whole robot to turn. And this will give you the number of revolutions. So just multiply by 360 to get the number of degrees. And then we just have to pass this on to the motors. So same thing here. We're just going to say the left motor has to go reverse in this case because we're turning left, and the right motor has to go forward because we are turning left. Next, you want to pass it the speed. You could create a speed parameter here, like in speed. So you just input the speed every single time. I personally don't like doing that because half the time, all the time, I personally don't like doing that because for me, the speed stays constant almost every single time. So what I usually like to do is I just go up here, I say I have an integer called turning speed, and I just set it to 45. I'm keeping it fairly low because you don't want your robot to turn super fast and overshoot. And then this is going to be the turning speed and the turning speed. And that's that. And like how we copy pasted go forward to get go backwards, we'll do the exact same thing for turning right. So we'll change the name to turn right. I might want to capitalize that, to turn right. And then we have to switch these around because when we turn right, the left side of our robot has to go forward while the right side drives backward. So this is going to be forward and then this is going to be backwards. And that's that. We have 4 basic functions for driving the robot around. We can drive forward, backwards, turn left, and turn right. And we're able to input a distance and a speed, or the number of degrees we want to turn. So now we can use this directly in the autonomous code. So say, for example, I want to go forward 10 inches at a speed of 75, then it's a piece of cake. Because otherwise, every time I wanted to go forward, I would literally have to rewrite these 3 lines over and over and over again. So all this is just condensing it into one quick and easy line or function. So it's much easier now.